This is Linear and Exponential Growth and Decay by Grey and Ailin.
For our first problem, we have John is training for a marathon. He runs every day and starts by running 1 mile for the first week. He finds that he can run 30% further each week. So, the recursive rule would be now times 1.3 for our 130% increase, or our increase by 30%, and then the 100 is there to make it an increase, equals next, starting at 1 mile. And the explicit rule would be y equals, our start value is 1 times 1.3 for 130% to the x power. After either of these equations are applied, we get this table showing that each value, y value, will increase by 30% every time, giving us 6.27 miles at week 7. And if we graphed this, it would look like this, with an exponential growth showing us the curved line that gets steeper and steeper as time progresses. And now for the questions. Our first question is, when will he be able to run the full marathon? Now we know that a full marathon is 26.2 miles. So if we plug that into the calculator, we'd get that when we surpass 26.2 miles, it's in between 12 and 13 weeks. So therefore our answer would be in between 12 and 13 weeks. Our second question is, after 10 weeks, how far will he be able to run? Now we can just go back and look at the at the table and see that at 10 weeks, which is right here, he'll be able to run 13.79 miles. So we can go back down and write 13.79 miles. Our second problem is a linear growth problem. Adam got a new piggy bank and is going to collect his money. He has $20 to put in right now and is going to add 25 cents every week after that. So our recursive rule is next equals now plus 25 cents. He gets 25 cents every day, and he starts at $20. The explicit rule is y equals 0.25x plus 20, because he starts with $20 and adds 25 cents every week. The table would look like this, with $20 as our starting value, and at 9 weeks he would have $20.25. If we graphed it, it would look like this, starting at $20 and going up linearly, or a straight line from there. Our first question is, how much money will he have after 15 weeks? Well, if we go over to the table, we can see that at 15 weeks he'll have $23.75. So after 15 weeks, he'll have $22.75. And the second question is, when will he reach $30? Well, our graph says that at 40 weeks, he'll reach $30 in his piggy bank. So we can say for the question, at 40 weeks.
Our third problem is linear decay. Melanie's friend gave her a box of cookies for her birthday. There are 120 cookies in the box. Melanie plans to eat 4 cookies every day. So our recursive rule is start equals 120, and then next equals now minus 4. Our explicit rule is y equals negative 4x plus 120 because we start with 120 and our slope is negative 4. This is our table because we start with 120 and subtract 4 for every day. This is our graph, and it's straight because we have a linear decay instead of an exponential one. So it's straight. Our first question is, after 12 days pass, how many cookies will be left in the box? And to figure that out, we need to go over to your calculator and put in the equation and go to the table until we find 12 days. And we can see that it's 72. So the answer is 72 cookies. Our next question is, at what time will the number of cookies in the box be less than 70? And then to solve this problem, we will need to plug 70 into the y. So it will be 70 equals negative 4x plus 120. And then we subtract 120, which is negative 50 equals negative 4x. Then we divide negative 50 by negative 4, and we get x equals 12.5 days. Finally, this is our exponential decay. Exponential decay, a new wolf pack has moved into the forest. Before they came, there were 250 rabbits. The wolves are eating the rabbits, so the rabbit population decreases by 25% each week. The recursive rule is start equals 250 rabbits. Next equals now times 0.75. We multiply by 0.75 because we decreased by 25%, so 0.75 are left. The explicit rule is y equals 250, because that's our start value, times 0.75 to the x power, because that's how much we're multiplying by. When we plug this into our calculator, this is our table. For every week, 75% of the rabbits are left. This is our graph. Unlike the previous graph, we can see that this is a curve because it is exponential decay. Our first question is, after 4 months, how many rabbits will there be? And to solve this, we have to plug it in our calculator and see. So 4 months is 16 weeks, so 2.5 rabbits. But for rabbits, we have to have a phone number, so we round that to 3. So we write 3 rabbits. Our last problem is, after how many weeks will the rabbit population go extinct? And to find out this, we need to scroll over. An extinction is when the number reaches 0 in the y column. So when it rounds to 0, it's between 21 and 22 weeks. So we go back and we write 21 to 22 weeks.